Okay, so today I'm going to be working on building a temperature controlled extension cord. This is an extension cord, of course. It's a short one, but this is, more importantly, it's a 4-into-1. I have several heat cables that I'm going to be using to keep pipes from freezing, so I needed something with several outlets on it. Some people use thermal cubes. This is going to be plugged into an outdoor outlet with a cover on it with a door. So I really didn't want anything, well, actually a thermal cube really wouldn't fit in one of those things. So I'm going to be modifying this to come on at 35 degrees Fahrenheit and shut off at 45. My solution, I guess some of the thermal cubes have been having reliability problems. I mean, I don't know that for sure, but I was just reading reviews on them. So I decided to go with something I know works, and this is a snap disc thermostat, they call them. Some are adjustable, this one isn't, and this comes on at 35, goes off at 45. And this is one of those things like you would have in a dryer vent that keeps the house from burning down. Of course, that would be set to shut off at a much higher temperature, obviously, but it's the same principle. And this is what I'm going to use in line with this cord here to control the temperature switching on and off. And then I will use some shrink tubing, heat shrink tubing around that to seal everything out of the weather. Okay, so I'm just going to go ahead and bend the ears over on this thing since I'm not going to be needing them. I could cut them off, but I really don't want the sharp edges. Just go ahead and bend them over. Probably the easiest way to take care of this excess material. So I just went ahead and folded those tabs over a couple times, and then I squeezed them lightly in the vise just to bring the profile down a little bit. And that way it slides freely through there. That'll work pretty well. And yeah, this is, by the way, this is I believe it is 1.25" shrink fit tubing. So stuff's expensive, but it works really well. And by the way, this isn't necessary. Really, you could use electrical tape. As long as it's high quality electrical tape, it'll keep out rain, it'll work fine. I just got this to give it a more finished look. And I'll show you here quickly how this works. I put it in snow to turn this switch on. You'll see the resistance here. Pretty much almost nothing. And as it warms up, there, see, it just snapped. It went to overload. Went to infinite resistance just that quickly. I set it in the snow just to, and you can actually feel it snap when the temperature goes down. And as soon as it comes in here and warms up a little bit, the switch turns back off. They're pretty cool, actually, and highly reliable. This thing can take 25 amps, and I'm not even going to be close to drawing that much. I'm going to be drawing maybe 3-4 amps at most with this application. Okay, you see I have the insulation removed. I'm just going to go ahead and cut this hot wire. And I'll go ahead and strip these wires. Just a little bit. I don't have much room, so. I might take a little bit more off that side if I can. That's actually a little too much, but I'll make it work. That, and then these will get soldered on like that. Another thing I'm going to do too that will help save some room and make this a little bit more streamlined. So I'm going to bend these spade terminal tabs over just with a pair of needle nose pliers. I don't want to snap them in half, I just want to bend them over as gently as I can. That should be okay there, I think. Kind of leave a radius at the bottom so they don't get brittle. Just like that. And what I'll do is I'll solder these ends on and put the shrink tubing on. I had to shorten this one lead a little bit to get the spacing correct for these tabs to solder them on. So I had to increase this distance a little bit there. So I'm going to go ahead and start soldering these. I don't really care for the switch on this soldering gun. It goes low wattage, then there's a space, and then it goes to high, but there's no... It's kind of a tough keeping it in position because there's no indents in the switch at all. That's a little less solder than the other one, but that'll definitely hold. Okay. Now that part is together. I'm going to let that cool down a little bit. And I'm going to put some electrical tape on there just to keep everything in place until I get the shrink wrap on. Okay, that's cooled down a little bit. I'm just going to measure out a length of the shrink tubing. This shrink tubing, believe it or not, goes down to from 1.25 inches down to 350 thousandths, which is just below 3/8 of an inch. That's hard to believe that'll do that, but I tested a piece here yesterday, and this black collar you see on this reamer actually started out that diameter, and I used a heat gun on it and it shrunk clear down to the point where it's on there. In fact, I don't know if it'll ever come off. This is the kind of heat shrink tubing that has it has a hot glue in it that whenever this melts, that hot glue squeezes out and makes a weather-tight seal on anything it's on. You see that clear film on there. It's the consistency of hot glue, and it clearly glued itself on here. I'm gonna have to heat that back up to get that off of there. This stuff's pretty for real. So then that's what I'm gonna be using on here. It's expensive, but it's good stuff. So I'm gonna go ahead and trim this to size. So like the best quality scissors, I could have got my good ones out, I guess, for this, but go and slip that thing on there. And you want to make sure it's on center. Doesn't have to be perfect, but kind of get it, feel to make sure it's in the middle there. That's pretty close. And like I said, it doesn't have to be perfect. Go ahead and grab the heat gun here. I'm used to working with the real small heat shrink tubing, like the 3/8 and 1/2 inch material. So this requires a lot more heat, I see. Looks like it's a little bit off center there. I'm going to try to move that a little bit. There, that's good. I always start in the middle to kind of lock the tubing in place. Okay, so I let this cool down for a while, and here's the finished product. You see the sealant there? It came out. That makes the whole thing waterproof. Everything's encased in shrink tubing and glue. Okay, let's see if this thing actually works. Now I have a outlet tester right here. I'm going to plug into this extension cord that I made a while back. Now you see it showing a normal circuit glowing. Let's plug this in here. Plugged in, and being it's not 35 in here, this isn't going to come on. See, it's not on, but once it gets below 35 this should turn on. So let's check it out. Let's take it outside and see how long it takes for this to come on. So here's the tester light has just come on, and it's not real cold out here. It's in the lower 30s I think, but there's some water out here in a bucket. It hasn't frozen and the snow's melting, so I think it's not quite, it's not quite 32 here, but this thing turns on at 35, so it's right on the edge of switching on and off. I'll show you how sensitive this is though. If I grab a hold of this disc, within a matter of seconds this will switch off. See, that only took about less than 10 seconds to switch off. It'll take about another minute or two for it to come on. But that's what I mean. If that was in the 20s or teens, it would take a lot longer to warm it up. Well, this next thing I'm going to do with the switch should be interesting. I hope you'll find it interesting. And what I did was I put the switch in the shop for a while and let it warm up quite a bit. And I brought it back out here and wired it up to a I guess you could call it a device. And now I'm just going to wait for the switch to cool down enough to switch this device on. So it's going to take a few minutes here. I'll edit this, so you don't have to wait too long. But when the switch comes on, you'll definitely know it, and I think you'll find it interesting. That was cool.